Okay, welcome back. Let's take a look at one last thing, which is what we're doing at the very end of the week, which is how do you take data like a table or possibly a graph, because really the graph can be turned into a table very quickly. How would we take that table or that graph to come up with the equation that was giving us that value? And so that's what we're going to look at in this particular set of videos. So we'll start off right here, and I have a nice little table of values here. And what I hope that you can see is that there is some very nice symmetry to my table right here that I have. Everything seems to be centered around this value right here. Notice these numbers are receding away from it in a nice uniform way. I noticed that from here to here, it went up 2, and then it went up 6, and then it looks like it went up from here to here, it went up 10, -1 plus 10. Well, remember we started with our little 1, 3, 5 pattern, right? But what happened to this pattern to not be 1, 3, 5, but to be 2, 6, 10? Well, the only way that would happen is if that pattern got doubled. So I know for a fact that my answer has an A equals 2 in it. So down here, I'm going to start writing out what my formula is. It would be a 2x squared. Now, with that being stated, I have another little thing that I know that my line of symmetry was handed to me right here, that somehow opposite b over 2a has to be the number 1. I was already given that line of symmetry early in the problem. But since I already know what a is, I would know that opposite b over 2 times 2, which is 4, has to be 1. Well, if I were to cross multiply, then I could say that negative b is equal to 4, which makes b equal to -4 if I divided both sides by -1. So I'd have minus 4x. So I already have a and I already have b, and I have one piece left to go, which is c. But remember, c is always my y-intercept, which in this case I gave you right here. My y-intercept happens if you plug in 0 for x. So I know my c value is -7, and very quickly I was able to utilize the pattern to get A. I was able to use my line of symmetry to find B, and then I was able to use a quick observation about my C value here. So let's do that again. So again, going back to the ax squared plus bx plus c, I'm going to find the center of my story, which is right here. So I know my opposite b over 2a is somehow supposed to be the number 3. But I also know that in my pattern, it looks like it went down 1, not up 1. It went down an additional 3 and then down an additional 5. So it looks like my pattern, instead of being a +1, +3, +5, became a -1, -3, -5, which tells me that a value better be -1. So I'm going to start writing my summary statement down here, that it'd be -1x squared. And you know what? I think I'm going to go ahead and do one other thing, because I know right here that if I plugged in 0, I got 5. So I know my C value is a +5. So the only thing I haven't yet found was B. Now, again, this is the part that I know is going to be a little bit tricky for some people to watch. But right now, I know that A is -1. So what is 2 times -1? That would be -2. So somehow a negative B over a -2 has to be 3, but we should know, everybody, that a negative divided by a negative is a positive. So some number divided by 2 has to be 3. Well, that number would have to be the number 6. So there we go. That would be our second formula that we have. And again, if we wanted to double check, like we said, sometimes it's a really good idea to check and make sure we haven't done something silly. We could try a random number, and I think I just decided I'd try this one right here. So let's see what happens if I plug in the number 5 for x in both places, and let's see what happens. -5, see 5 squared is 25, and put the negative afterwards. 6 times 5 is 30. -25 plus 30 is 5, and 5 plus another 5 makes 10. So I just picked a value and I checked it, and it seemed to work. Okay, 2 more real quick. So this one obviously is going to catch people up a little bit and go, oh no, there's like a fraction involved in it. We've got decimals going on. So let's see what we can figure out. So I'm going to find the center of my table right here at -3. So again, I know that opposite b over 2a is going to be -2 somehow. I also can see that it went up 0.5, and then it went up 1.5, and then it went up 2.5. So it looks like my 1, 3, 5 pattern got cut in half, because a half of 1 is a half of 3 is 1.5, and a half of 5 is 2.5. So again, summary statement, I have 1/2 x squared. And if you wanted to say 0.5, that'd be fine. But now let's see, opposite b, because we don't know what b is, that's what we're trying to figure out. But if I doubled a, I just found out that a was 0.5. If I double a, I get 1. So somehow when that happens, I'm supposed to get the number -2. Well, the only way that can be happening is if the opposite of b is -2, so b itself is 2. So I know b is 2. So I got 2x. And last but not least, if we look for 0 in my table, there it is. I know that 0 happens at -1. And so now I've got it. Now again, a little trickier problem, so you might be a little bit more nervous, but if you'd like to plug in a number, you could check that, and that would be no big deal. Now, the last question I decided to put in here is right here, and I did that on purpose because if you look at it, you're going to notice that there's a number that is not here. I never gave you the number 0. Bummer. Now, that doesn't mean you couldn't go ahead and make the table get bigger, but sometimes 0 may be really far away from your table and you just don't know how to get it. So let's talk about what we do. So the first thing I'm going to do is I'm going to locate the center of my table. So I know that opposite b over 2a is going to be -4. And I can see that the table went up 3. Wow, that's interesting. Haven't done that yet. And then it went up 9 right here, but the table kind of ended quickly. But let's see, this way it also went up 9. But then right here it went up 15. So my 1, 3, 5 was 3, and then 9, and then 15. So it looks like it got tripled. So it looks like my a value is 3. So I've got 3x squared. Remember, we're looking for ax. Oops. I'm looking for ax squared plus bx plus c. And I just found out that a is 3. But if I did the opposite b over 2 of those, let's see, opposite b over 2 of those a's has to be -4. So I'm going to cross multiply, and I get -b equals -24. So I guess that makes b positive 24. If the opposite of b is negative, then b itself must have been a positive. And now we have one last thing to figure out, and that is what in the world was that last number that I'm missing, which is C. So what we can do is we can just call it C for a moment. We don't know what it is, but let's just pick a number of our choice that we want to try. And so I think I'm going to try -2. So somehow if I plug in -2 for X, again, I don't yet know what C is, but according to my table, my Y value, if I plug in -2, is supposed to be the number 14. So let's see. -2 squared is 4, so that'd be 12. 24 times -2 is -48 plus C. Now, I do want you to mention something before I finish. Notice these are not in a 2-to-1 ratio because I was not plugging in the vertex. I could have plugged in the vertex and that would have happened, but I picked a random number down here, which was not the vertex. So if I put these together, these add up to -36. So let's go ahead and get rid of that by adding 36 to both sides, and 14 plus 36 is 50. So I just found out that C is 50. So my final answer is 3x squared plus 24x plus 50. And we've got all three values, A, B, and C, for our quadratic. And again, I did mention the idea of graphing, but keep in mind, if I handed you a graph, you could literally just go in there and find some numbers right off the graph and write them down and use that pattern. So hopefully that was helpful. I will see you back in class soon. Bye-bye.